Hi friends, I am Gaurav and I will be teaching you physics. So the first chapter is Kinematics. This is actually chapter 3 from S.C. Verma part 1. So the first topic is rest and motion. So one of the things to note here is that nothing is at absolute rest or nothing is in absolute motion. There is always a frame of reference, an observer involved. So here is the observer. The observer is sitting at this point. This is the origin. Origin O. Suppose here is the object. So it's x and y coordinates are x1, y1. At point t is equal to 0, if this object is at x1, y1. Suppose this moves in a circular fashion and reaches here. So this will be the displacement A, C, B. So this AB from A to B, this AB vector will be the displacement. This ACB, the path covered, will be the distance. So obviously the magnitude of ACB will be greater than the magnitude of AB. Here AB is vector quantity, ACB, that is the distance covered, is a scalar quantity. Now what is the speed and what is velocity? This body moves from here to here, but not in a straight line. This moves like this. So A, this is point A, this is B, this is C, suppose. So displacement will be this AB vector. So how do we get to the AB? This is R1 vector. This is the position vector of point A. This is R2 vector. Position vector of point B. Displacement will be R2 vector minus R1 vector. Speed will be simply the distance s by t2 minus t1. If we write instantaneous speed, it will be v is equal to ds by dt. If we want instantaneous, this is average speed. This is instantaneous speed. The average velocity will be v is equal to r2 minus r2 vector minus r1 vector by t2 minus t1. The instantaneous velocity will be d by dt of r vector. So one thing to note here is that magnitude of instantaneous velocity. The magnitude of instantaneous velocity will be the same as the magnitude of instantaneous speed. But for average velocity and average speed, the magnitudes will be different. Why? Because the distance covered is huge, but the displacement is this small. So therefore, the speed will be large. Average speed will be more than the average velocity. because for average velocity we are considering only this much length, but for average speed we are considering this whole length. But for instantaneous speed we are covering this will be approximated to the same. This will be approximately same. ACB and AB will become the same. So therefore, when it will become same? When the time t2 minus t1 is extremely small. So this was one of the concepts, that magnitude of instantaneous speed and the magnitude of instantaneous velocity will be the same. Now what is acceleration? Acceleration is dv by dt, the rate of change of velocity with time. Now suppose acceleration is a constant. We can actually integrate these sides. Suppose acceleration is a constant, so we will move it out of the integral. So this becomes v minus u, final velocity minus initial velocity, is equal to a into t. This is actually t minus 0, because initially the time was 0. So this becomes at. This is one of the formulas. V is equal to u plus at. You can note this down. This is one of the important formulas in kinematics. Now suppose, what is V? What is V? We will move to the second formula. V is nothing but dx by dt. So we will replace here in this equation 1, dx by dt is equal to u plus at. So dx is equal to u plus at into dt. We will integrate here. This becomes s for the distance travelled. Since we are talking about speed here, so this is the distance travelled. This is ut plus half at square. This is the integration of t dt. If we integrate t dt, we integrate t dt to a from 0 to t. This will become t square by 2. So it will become half at square. This is another formula of kinematics. Now for the third formula. We have this v is equal to u plus at. Now we will square both the sides. V square is equal to u plus at whole square. This becomes u square plus a square t square plus 2 UAT. Now here U square plus, we take common, what can we take common? 80. This becomes 80 plus 2U suppose we take it common like this. A, this becomes half AT square plus UT. So we get the UT plus half AT square, which is nothing but the distance covered. So we get U square plus 2AS. V square is equal to U square plus 2AS. This is the third formula.